Hi students, now I am gonna discuss problems on full wave rectifier. In the earlier lecture, uh, we discussed the problems on half wave rectifier. Anyway, my name is Dr. Ravi Kumar, Associate Professor, Department of EC, Institute of Aeronautical Engineering. We know that basically a rectifier is an electronic circuit which converts AC input signal into pulsating DC output signal. The practice problems on full wave rectifier, basically they have given the complete FWR rectifier and some parameters mentioned. Again, we need to find out some the characteristic parameters of rectifier like full wave rectifier, DC voltage and RMS voltage and like ripple factor, and then efficiency, peak inverse voltage, and what is the frequency output to full wave rectified output frequency, all those things. And we will see some problems. So if you see this problem, what is the most important thing is that first read the problems and then write down the given data, and then what are the relevant equations relevant to derivations required, note down it, and then we can apply those relevant derivations or relevant formulas, then we will get this answer. Basically, two types of rectifiers, half wave rectifier and full wave rectifier. Full wave rectifier, again, we can divide it into two types: full wave center tap full wave rectifier and bridge rectifier. So this problem regarding to full wave rectifier, center tap full wave rectifier. As we know that the center tap full wave rectifier is like the primary transformer, the AC input voltage Vin, and the secondary coil is center tap. Like the secondary RMS voltage can be divided again further into half, and one cycle the step down voltage, secondary voltage, is appear across the above center tap transformer like this, and then the below center tap transformer is quite opposite with this, like that one. So when it is positive cycle, the same time the negative cycle across the voltage across the secondary center tap to with respect to the like edge of this the down secondary coil. The up secondary coil edge with respect to this center tap is having positive cycle. Similarly, when it is negative cycle on the above center tap secondary coil, so at the same time it will have a positive cycle. So this is the kind of thing happened in this full wave rectifier, and we know that operation of the full wave rectifier, each time there are two diodes, D1 and D2. This D1 and D2, these two diodes are on, like it gets on at a time only one. During positive half cycle, one diode gets on. The same time, like after that, during negative half cycle, the opposite diode D2 gets on. So that totally during full cycle, positive half cycle and negative half cycle, either one of diode gets on, so that it will conduct full cycle. You will get the output waveform. The output waveform you will get during positive half cycle, it will conduct. During negative half cycle of the input, again it will conduct, and it will allow this positive side only. So like this, you will get the full wave rectifier output this way. So during negative half cycle, you will get this one. So now with the help of for this rectified output voltage, this voltage, what will be the DC voltage VDC? Already we have derived the equation 2 into Vm by pi, where it is the V input and the secondary voltage V2, like V1, you will get V2 here. This secondary voltage V2 again divided into V2 by 2, V2 by 2. This is called RMS voltage. The primary voltage and the secondary voltage just step down. So it is always measured in RMS only because it is in a still in AC. This secondary voltage V2 measured in RMS is divided in our due to step down transformer divided into V2 by 2, V2 by 2. This V2 by 2 is converted to maximum voltage. That voltage is given to the diode. What is the formula for maximum voltage? Vm is equal to, the maximum voltage Vm is equal to basically root 2 into VRMS, where VRMS here it is root 2 into which type of RMS voltage come to upside and either upside or downside. So we will take that V2 by 2. That V2 by 2 is taken as this VRMS here. So V2 by 2 is the second half or first half of the secondary coil of center tap transformer. So once we get this Vm, we can substitute this 2 Vm by pi, then you will get VDC. If we consider, every time I used to say, like whenever the problem considered with the secondary coil resistance, practical resistance, and diode is not an ideal. It has internal some forward resistance and load resistance. If we consider all those things, then we take this subtraction of the drop across secondary coil and forward resistance. At that time, we will take this VDC in this way. And VRMS, basically, VDC, this 2 Vm by pi, VRMS nothing but Vm by root 2. So we'll take that Vm by root 2. And ripple factor VRMS by VDC, or square root of VRMS by VDC whole square minus 1. You will get 40% of ripple factor in the full wave rectifier. And efficiency, the DC power delivered to the load divided by AC power given to the primary of the coil of the transformer, or primary like AC input to the rectifier into 100 is equal to, you will get approximately 81% in the full wave rectifier. Peak inverse voltage 2 into Vm, and frequency 2 into F5, because that's a cycle gets like repeated only every half cycle. In the time period, basically this is the input, AC input signal. The time period for this input signal is one of positive half cycle and negative half cycle. But you will get the output in the rectified output, full wave rectified output, the time period gets down 1 T by 2. Then the frequency gets doubled, 2 into F into I. So that's why the frequency is 2 into F5. So by maximum, when we know the maximum voltage using this formula, then we will get the maximum current. Im is equal to Vm by RL basically. But if there is secondary coil resistance and a forward diode current, if we would consider those two parameters, then the formula is Im is equal to Vm by Rs plus Rf plus RL. By using all those formulas, we will do this problem. Okay, let us try to read this problem and write down the given data and find out the problem. In a full wave rectifier, the transformer RMS secondary voltage, transformer secondary voltage from center tap to each end of the secondary is 50 volts. So this is the transformer. This is the center tap. The end of the secondary coil, the end of the secondary center tap to end. This, the voltage is 50 volts. This voltage. It is mentioned in RMS, means it is not maximum voltage. It is a secondary coil voltage. That too, half of the secondary they have given. It is mentioned that the transformer RMS secondary voltage from center tap to each end. Center tap to each end, not complete secondary voltage. So, one center tap to one each end. You will get 50 volts. This one, for example, this is the maximum, 0 to maximum, 50 volts. So, we can mention that one. So, basically it is V1 and V2 is the total secondary voltage, but that V2 again gets off above from center tap to above edge and center tap to below edge. So, V2 by 2 above, V2 by 2 below. But it is given in a value is equal to 50 volts. So, V2 by 2 value is equal to 50 volts. So, directly I can take that value is secondary voltage. V2 secondary voltage, one of the secondary voltage is 50 volts. This is the given data. Remember it. So if we could not confuse with this parameter, find out the VM, then everything is substitute in the formulas and then you will get the answer. So it is only thing you have to keep in mind that how to find out maximum voltage. It is a center tap. Remember that if they have given only secondary voltage, take that voltage into half and that value is considered to the maximum voltage. That value considered and then substitute in the maximum voltage formula. Okay, here it is mentioned already. The RMS secondary voltage from center tap to one end, each end. So already given the dividend value, divided voltage 50 volts. Load resistor RL is equal to load resistor RL is equal to 900 ohm. The diode and the diode resistance and transformer secondary winding resistance together has resistance 100 ohm. So it is mentioned that it is not an ideal diode, it is not an ideal secondary coil. It has some resistance. So that resistance can be considered secondary coil resistance and forward resistance together is given 100 ohm. Okay. So find out the average or DC current. DC or average. I average or IDC. And another parameter need to find IRMS. If you want to wish, you will find out the ripple factor, you will find out the efficiency, you will find out the peak inverse voltage, all those things. Okay. So, in order to find out the IDC, the formula for IDC is equal to here I average. Here it is. We need to find out the maximum voltage. We require maximum voltage. So, I average formula or IDC is equal to 2Im by I. Where Im is equal to maximum voltage is equal to Vm by Rs Rf plus Rl. How to find Vm now? Vm. How to find Vm? Once Vm, you substitute into Im. Once Im, you will substitute into IDC. Vm is equal to basically root 2 into secondary coil voltage. Here it is center tap transformer root 2 into 1 half of the secondary coil voltage, not complete secondary coil. The secondary voltage again divided into 2 of that voltage is given here. So that value already mentioned in the problem is 50 volt, which is equivalent to this value is equal to 0. Like 70. So root 2 into 50 volts. Vm. Then Im is equal to Vm by Rs Rf plus RL. Vm is equal to root 2 into 50 divided by Rs plus Rf combining together is given the problem like 100 ohm, and the load resistor is given in 900 ohms, totally 1000 ohms. So root 2 into 50 divided by 1000. So it is like root 2 by 20, which is equal to 0.0707, which is equal to 70.7 milliampere. Im is equal to 70.7 milliampere. Once we know the Im, that Im is substituted into average current. IDC is equal to 2 Im by I, where since formula we know that VDC is equal to 2 Vm by pi. Okay. IDC is equal to 2 Im by pi. 2 into Im already we got 70.7 milliampere divided by pi. You will get 45 or 44 milliamperes, approximately 45 ampere. The DC current across the load is 45 milliampere. What about RMS current? RMS current is nothing but Im by maximum current divided by root 2 for full wave rectifier, Im by pi, Im by 2 for half wave rectifier, Im by root 2 for full wave and bridge rectifier. So Im we got 70.7 milliampere divided by root 2. You will get 50 milliampere IRMS. Right? So this way we'll find out two parameters. This is A, this is B. The problem is given. What is the this one? DC value, DC current delivered to the load and RMS current delivered to the load. 45 milliampere DC current, 50 milliampere for RMS current. If you wish to find out ripple factor, the formula you can substitute that one. Square root of VDC, VRMS by VDC, VRMS by VDC whole square minus 1, or IRMS by IDC whole square minus 1. Approximately you will get 40.6, 40%. If you substitute, we have a RMS 50 by 45, you will get approximately, here it is 50 by 45. 1 point something 1 square, you will get 40%. And efficiency, if substitute, once we know the VDC and VRMS, if you want to VDC, directly use the formula VDC is equal to Vm by pi. We know the Vm. Vm is equal to root 2 into 50, means some 74 point something. 1.4 means 64 something you will get it. So 2 Vm by pi, 2 into Vm by pi, you will get VDC. VRMS, Vm by root 2, you will get VRMS. By substituting all those things, you will get triple factor. You substitute efficiency, if you want efficiency, PDC by PAC into 100, you will get efficiency. How to find out PDC? VDC square by RL, PAC, VRMS square by RL. By substituting all the parameters, you will get the answer. Next one, a Folio rectifier delivers 50 watts to the load, 200 ohms. If the ripple factor is 0.01, calculate the AC ripple voltage across the load. A Folio rectifier delivered to 50 watts to a load, means DC voltage delivered to the load. DC power delivered to the load is 50 watts. And RL is given 200 ohms. And ripple factor is given 0.01. Calculate AC ripple voltage. AC ripple voltage means RMS, ripple always measured in RMS. VR RMS. AC VR means ripples. ACR ripples. Or RMS, measure RMS. What is the VR RMS? We know the formula for ripple factor. Ripple factor is equal to, one of the formula is ripple value, RMS value of the ripple, VR RMS value of ripple or AC by VDC is nothing but ratio of VR RMS by VDC is nothing but ripple factor. So now we need VR RMS is given, ripple factor is given. Just find out the VDC. How to find out the VDC from the given data? The given data, PDC basically, formula for PDC power formula is VDC square by RL. PDC is given, RL is given. So VDC square is equal to PDC into RL. What is PDC? 50 watts. What is RL? 200 ohms, which is equal to 10,000, which is equal to 10 to the power of 4. So VDC square is equal to 10,000. VDC is equal to square root of 10 power 4. Nothing but 100. DC voltage is equal to 100. Then substitute in the ripple factor. Ripple factor is given already. 0.01 ripple factor is equal to VR RMS by VDC is equal to 100. So VR RMS is equal to 100 into 0.01. You will get 1 volts. VR RMS AC voltage required to get that ripple factor 0.01 is 1 volts. So in this way, if we want to find out the problems, we need to require some relevant formulas like VDC, VRMS, IDC, IM, and ripple factor, efficiency, all those parameters. Try to understand the problem and try to write down the given data and then solve the required parameters. So here it is, calculate the AC ripple voltage VRMS, which is equal to 1 volts. In this way, we find out the problem. But once again, I repeat that remember carefully, find out the maximum voltage of the secondary voltage. So in this case, this lecture, I discussed about full wave rectifier. So always think about what is the maximum voltage in the center tap transformer. You must consider that secondary voltage again divided into two halves. So that voltage substitute in the formula of the maximum voltage Vm. So and finally, once again you remember these two problems taken from this question bank, and if you want more problems regarding to rectifier, take collected from the electronic devices and circuit by Salivahan. So every time you must keep in mind that always they have given transformer parameters and transfer ratio, center tap. This is V1, this is V2, and V2 by 2, V2 by 2. That is comes under Vm. Now Vm is equal to root 2 into whatever you got in the secondary, one half of the secondary coil in the center tap transformer. So for example, it is total secondary voltage, but it is V2 by 2, V2s by 2. So V2 is V2 which is equal to V2s by 2. Okay, so root 2 into V2 is so important. Once we know the Vm, you substitute everything. If it is not center tap transformer, whatever the secondary voltage VTS, that is multiplied by root 2 into VTS, is nothing but Vm. You remember it. So once you don't have any confusion with that, then you will easily find out the remaining parameters. This is all about problems on Polio rectifier. We will see in the next lecture regarding to bridge rectifier problems.
Like, share and subscribe. Hit the bell icon for more updates.